Hello, everyone, and welcome to the Trenchless Technology webinar series. I'm Sharon Bueno, editor of Trenchless Technology magazine, and it's my pleasure to introduce today's presentation, HDPE Piping Systems, the Right Choice for Trenchless Projects, presented by Core & Main and the Alliance for PE Pipe. We're going to take care of a few housekeeping items first, and we're going to kick that off with a quick poll. So please submit your answer and then click the blue Return to Presentation button. I also want to say that any views or opinions presented in this webinar are solely those of the presenters and do not necessarily represent those of Benjamin Media, nor does Benjamin Media endorse any products or methods presented. Presenting today's webinar are Rusty Reeves, Peter Dyke, Dan Landy, and Alan Ambler. Let me tell you a little bit about each of our presenters before we get started. Rusty Reeves is National Director of Fusible Products for Core & Main and is heavily involved in the Plastics Pipe Institute and the Alliance for PE Pipe. He has over 32 years experience in the HDPE piping systems industry and has provided HDPE solutions to international, municipal, water and gas, and mining and industrial markets. Peter Dyke is the Executive Director of the Alliance for PE Pipe, and he's tasked with educating public utilities and the engineering community on the features of HDPE pipe and how to best integrate it into existing U.S. municipal water and wastewater systems. He has over 30 years of experience working in the public sector, serving clients, managing complex municipal construction projects, and advocating for issues at the federal level. Dan Landy is one of the newest members of the PE community. He joined the Alliance for PE Pipe to support ongoing operations as well as spearheading new initiatives. He is the first member of the Alliance's engineering program, which was established to research, connect, and support utilities in their adoption of HDPE. He edits engineering specifications, handles technical cases, drafts technical documents, and hosts webinars to aid in conversions to HDPE. Alan Ambler has 21 years of diversified experience in utility operations management, utility planning and engineering design, roadway and drainage design, multi-jurisdictional coordination, and construction management. Through his work at AM Trenchless, Alan has become a national leader in trenchless technology methods, such as pipe bursting, and has become a national expert in understanding the application of complex government regulations, such as the application of the National Emission Standards for hazardous air pollutants for asbestos cement pipe bursting. Following the presentation, there will be a Q&A session. We encourage you to participate by typing your question in the designated panel on the left-hand portion of your screen. You can also maximize your viewing window by clicking the box with the X at the upper right of the slides. Now, please let me welcome our speaker, Rusty Reeves.
Hey, good afternoon, everyone, and thank you so much for joining us this afternoon. I think we have a really good, important information to share with you. I wanted to thank Trenchless Technology magazine for hosting us. The Core & Main is a waterworks company. We are nationwide. We have over 300 branches, and as far as the polyethylene goes, we have over 500 fusion units to accommodate whatever sizes or applications that you have, including some in-ditch units, which are very key for doing the type of projects we're going to be talking about today. We have a lot of information to cover, so we're going to go fairly quickly. One thing I did want to mention was we can take questions as we go through the program, so feel free to send your questions in. Dan Landy will be helping answer those questions, and then we'll have some time at the end. Also, we have a lot of, we're going to have our contact info up. We're covering a lot of information. If you have questions or want to discuss projects or anything later, feel free to contact any of us. We'll be happy to help you with the answers or provide a contact that can do that for you. So again, we want this to be an ongoing learning experience. With that, I'm going to pass it over to Alan Ambler. Alan?
Well, hey there. Glad to see everybody. Well, I can't see you out there, but glad that everybody's out here on there. So it looks like we've got pretty good attendance today. They tell me there's over 500 registrants. We also have a fairly substantial amount of experienced technical speakers for you as well. So Rusty had mentioned that we love questions. If you can find the question and answer portal for you there, you can type those questions in while the show is ongoing. And we've got Dan Landy, Peter Dyke, and Rusty Reeves, and myself that'll be looking at those questions, and I'll type answers for you as we move along. And then also, if that question is exactly what we're talking about and gives us the opportunity to really get down to the heart of a different topic that we're talking about, and it's perfect timing, then we will certainly answer that and discuss it live with multiple voices for you. So the Alliance for PE Pipe, if you're otherwise not aware, is a nonprofit organization that focuses on education itself on all things high-density polyethylene pipe. We do provide free resources such as this webinar with Trenchless Technologies. We also have a lot of our own webinars that we put on and with other agencies as well. But we often interface with consulting engineers, owners, contractors, or anybody that wants to talk about polyethylene pipe on a routine basis. So feel free to reach out to us. The email at the bottom of this slide will tell you, dlandy@pepipe.org, and he'll schedule a seminar with the nation's experts with you for your specific question, offer project review and assistance, and then spec writing and editing. We do those things for free for you as a nonprofit organization. Lots of good experience here in Trenchless technology projects, as well as any high-density polyethylene project that we're looking at for you as well. So some of the other free resources we have are the engineers package. So this is a very detailed, robust document for you that is free and downloadable on our website at pepipe.org, and it contains the Plastic Pipe Institute Handbook on Polyethylene Pipe, the Alliance for PE Pipe's Insider's Guide to PE Pipe for all that verbiage that you may otherwise not be aware of, or and you just want to be able to review it and double check that you got everything in tow for you there. But also we have typical details, specifications in both Word format and PDF format for you, as well as a lot of different technical notes as well. If you are curious out there and you're on the call, your municipality, or just got your feet touched in the water for high-density polyethylene projects, it's never fun to be the first, but we can pretty much guarantee you haven't been the first within the country on doing these projects before, and we've compiled a whole lot, very robust amount of case studies for you to be able to see that a lot of these projects have been done before. Today's team itself, we've gone over it. Sharon, thank you so very much for that wonderful introduction, but unfortunately can't see our faces in a live camera action as we're going through, but my hair's a little bit longer. Thank God I still have some in that scenario, but these are the people that are talking to you and also answering the questions as we go along through here as well. So today we're focused very specifically on trenchless technology projects and then also the use of high-density polyethylene pipe. So these are the four that we're going to be presenting primarily. There are more. There's a whole lot of detail in these, as you guys are well aware out there in the interwebs and the audience for us, that any one of these discussion items and these methods of high-density polyethylene installation or trenchless installation could be a full book, full 8-hour course in and of itself. So horizontal directional drill is going to kick us off and start. We do have a lot of ground to cover, so I'm going to be pretty quick and we're going to keep it high level. But what we say about horizontal directional drill in the high density polyethylene industry itself is it's the gateway drug for municipal use of high density polyethylene. So the majority of the first use of high density polyethylene for municipal people is through the use of horizontal directional drill. When we started to look at some of the statistics, as many as 60 to 70% of the municipalities in the state of Florida itself have used horizontal directional drill for high density polyethylene. We're also going to look at slip lining, compressive fit slip lining. These are similar in their setup, but one of the differences, compressive fit slip lining itself is the only product they can use is high-density polyethylene. So we'll talk about the setups, about what expectations are, cleaning that existing pipe as we go through, and then pipe bursting as well. If you're not otherwise aware of pipe bursting, it probably should have been called pipe fracturing instead of bursting, but that's all right. And essentially, we're taking that existing pipeline and we're pushing it into the 2 to 3 inches of soil that surround that existing pipeline, and we're pulling in that new pipeline for it as well. So we'll tell you all the ins and outs of these trenchless technology methods as best as we can in the short duration that we can. I already see we have 7 questions already rolled in. We're getting you guys answers to that. So thank you so very much. That is the way that this is going to roll out for you. Keep going. In horizontal directional drill, essentially we are crossing some type of an obstruction, whether or not that be a foundation or whether or not it be a river or water body, which is the most common. We are installing a new utility in this situation, in which case we're drilling a pilot hole at a sufficient depth underneath that water body. We are making sure that during this pilot hole drilling, we are locating where we're putting this drill in the appropriate place. Consulting engineers or other engineers will design a bore path in advance based on information that they collect about that project to make sure that we've got a safe and sound route to be able to put that bore path through, and then they'll start the process of going through the horizontal directional drill process. Once we have that original bore path put into place, we start to pre-ream or cut through that hole itself. Use of bentonite, which is essentially a very moist specific clay with lots of additives that are that secret sauce within the industry itself, start to help us remove that material within that bore path so we can start expanding it to the size, the high density polyethylene pipe that we are using to replace it or install into that bore path. And then once we have a sufficient bore path area expansion that we're looking at a hole, we start to attach to that replacement pipeline and pull that back into place. So for all of these processes itself, the limiting factor for the allowable radius is never the high-density polyethylene pipe. It is the ability for the equipment that is putting in the drill string and the actual bend radius of the drill string that limits the ability to install the high-density polyethylene at the depths or the curvature that we're looking at. Now, when we're looking at very long lengths of horizontal directional drill, we want to look at the tensile forces that can develop within the pullback as we move through that and compare them to the allowable tensile forces for high-density polyethylene. And there's lots of great references for you out there. NASTT's HDD Good Practice Guidelines 4th edition is a great book. ASCE has a manual of practice for you. ASTM standards, there's lots of great stuff out there for you. The Plastic Pipe Institute Handbook on Polyethylene has an entire chapter that's dedicated to horizontal directional drill. The Alliance has taken that a little step further, and we have specifications and spreadsheets for you to be able to look at some of the most common calculations that you'd be using here. So where we're looking at mostly in that tensile forces as they develop through pulling this pipeline into place is that curvature that you'll see developing between L4 and L2, points B and C along this, where we're looking at friction forces along that curvature there. So that's where we want to evaluate pullback friction forces against that curvature and make sure that we are able to address that. There's several different techniques to go through as well to look at buoyancy, ballasting that pipe. You could fill it with water to be able to make sure it's heavier as it sinks and then develops less frictional forces as we move through it. But there are lots of great tools out there for you in reference documents to be able to take a look at those forces and what they may be as we develop. So again, from the process that we worked out for the very first 3 slides. We're essentially going to start on one side. The difference between sizing we get to is around 12 to 16 inches. Under that becomes a mini HDD rig, and above that becomes a maxi HDD rig. They all vary in somewhat of the size, the tonnage that they have for these directional drills as we go through it, but the process is essentially the same as we look through this. So we're going to use that drill operator with drill string. Those are threaded connections as we go through that, so we want to make sure that they stay well maintained and then also lubricated as we're pushing that head through. Now, this is the smart head at the front of this that's being able to be located as we start to drill that original bore path. And what you'll see here is that locating device. It's often a 2-person crew here that moves along. This gentleman that you'll see with the inspector against the ground of that matter is really tracking the vertical and horizontal locations of that head of the drill string as it moves through. So they're able to calculate and look to see if they're following that designed bore path to make sure that the bore path as it's moving through meets the design requirements and bid documents that allow for the specifications of the tolerances for what the drill is trying to achieve in that manner. So while we're looking at this, that ductility becomes more important than strength of the pipe as we're pulling through. So obviously when we are starting to get at the end of that bore path where we have the diameter of the borehole reamed to where we want, and we're starting to pull that pipe back through there, there's going to be some lengthening of the high-density polyethylene material as it pulls back. So when that drill is actually completed, we want to give ample time for the drill to relax. Not the drill, the HDPE to relax as we go through it. So it's a very common practice to fuse on longer ends of the horizontal directional drill run that we've got to allow that to relax. Typically that happens in 2 to 24 hours. So we wouldn't reconnect at the final connections in that time period. But as you're seeing here, 50% of all of the drills we're looking at are high-density polyethylene. That's from small conduit, which is quite often used, all the way up to very large diameter force mains, potable water mains, and things of the like. We'll show a case study on a 54-inch force main here in a few minutes as well.
Alan,
we're looking.
Go back
yes?
to that one. I'll give you a quick breather too. But I mean, I think this is a perfect example of some of the really key benefits of polyethylene. You can see the pipe there in the background of this picture, looped around and ready to be installed, so that the fusion could take place. Many times the directional drilling or these other types of trenchless pipe installation can happen very quickly because the pipe is fused, ready to go. And again, there's not another piping material you can really loop around like you see on this. I know we've had some questions on the bending radius and everything on polyethylene. Just wanted to mention this is a perfect example of that. So.
Thank you very much. And then Rich Weeb, I hope I pronounced it right. I'm sorry if I didn't, Rich, for that question. He had asked about any damage that may occur to the pipe. The industry itself allows a 10% gouge allowance. So that way, if we get exterior damage of that pipe, as long as it's not more than 10% of the wall thickness, that pipe can be performed throughout the lifespan of its pipe. Of course, that's really difficult to look at in a horizontal directional drill procedure. But as we go through, the process and purposes of some of that bentonite is in order to be able to keep the pressures within that bore path and the bore hole high enough to push out the material that may otherwise fall into the bore hole in that scenario, and oftentimes that'll prevent movement of larger boulders or other things within the bore path. So hopefully we answered your question there in addition to what Dan or Peter may have as well. So definitely, Rusty, don't hesitate to jump in there and add any other color as well. So HDPE does allow those tightest curves, lighter and easier to handle during pullback as we're looking. So it's one of the most forgiving and durable products to work with in the field for any installation method. That's one of the true benefits of not only the design of the material when we're looking at butt fusion, which is actually a fairly quick procedure and durable procedure to fuse two pipe ends together to make that fusion as strong, if not stronger, than the actual pipe itself. That can be redone and redone and redone as many times. So, Rich, if we did find a section that was damaged and that beyond that 10% gouge that we talked about, then I say when in doubt, cut it out, which you'll see a little bit later. We'll just cut that section out, and then the contractor can fuse that pipe together in pretty short-term fashion, and then continue with that pull or application as we go through that. So, Rusty did show you the layout benefits. There's very little to understand about this besides seeing it. And what you're seeing is an extremely long pipe string that is put through in very small areas with tight bending radiuses that allow us the flexibility of the material. We're taking advantage of that material itself to be able to give us easier installation access as we go through there. So something with a smaller the bending radius itself. So, I mean, that means we have to, not as forgiving, it's a larger number that we're looking at. We'd have to put that out in a much longer fashion to be able to make sure that we have access, lay down access, and install that pipe as it is there. We did mention it's easy to handle. So these are two examples for us of the allowable bending radius for high-density polyethylene being very forgiving and getting these pipes into place. Very easy to move from the lay-down yard and then be able to make sure that they're having the appropriate insertion path as it gets put into the borehole as we go through. Here's a couple of other pictures. We're looking at another reamer on the left here in front of a swivel that pulls a head through. So we're making sure the front of that high-density polyethylene is sealed off as we're pulling that pipeline through. Again, this will have some rotation as the drill string goes, so that swivel allows us to reduce some of that frictional forces as we go through and the torsion effect. And we're going to continue to pull that right into that bore path as we've subsequently installed it and then back reamed it. And what you'll see on the right again is just more example of the forgiving nature of the allowable bending radius of high-density polyethylene as it's moved into place. There are tools available for you. So here you're looking at PPI's Boraid, which is an online website where you can easily go through and type in your potential bore path that you're looking at, whatever you might be crossing under, whatever depth it might be, information you have about soil conditions, the length of the pipe that you're going to be installing. Some of the biggest short sites we see in the industry is trying to make that bore path go down as quickly as we can and come back up as quickly as we can. So it looks like a U shape. And a lot of times that's limited in our entrance and exit angles from the equipment that is actually being used to install that pipeline, not the drill string or not. Definitely not the HDPE as we've seen before. So again, for you consulting engineers, you professional engineers out there, this is a planning tool, and then you should look back to PPI's Handbook on Polyethylene Pipe or ASTM standards or other things to do your calculations as you move forward and take responsibility for that bore path. Boraid is a very useful tool for us in the fact that it will compare multiple DR ratings. Now, DR rating, if you're not otherwise aware, the lower the number, the higher the pressure resistance as we go through. So a DR 11 is 200 PSI. It's often the industry standard for potable waters we go through. And then a DR 17 for gravity sewers we move through, and that's 125 PSI. So they will compare multiple different DR ratings and then also look at the tensile force while we're pulling that into place and then spit back some information for you and the place in the references as to where it comes from. So one of the interesting components about high-density polyethylene is its modulus of elasticity changes over time. This is due to the viscoelastic behavior of the pipeline. Just that concept and the word viscoelastic could take, oh gosh, I think we have 45 minutes to an hour on this concept alone when we have a much longer time period to talk about it, but I don't have that. So what we're going to say is essentially the material behaves both in elastic behavior, where like a rubber band, it'll just stretch out and then go back to its shape. But then it also a viscoelastic behavior where over time, if we continue to have that load applied to it, it'll have some terms of creep where it'll settle. So when we're starting to pull that pipeline into place, most of this pullback, we want it to try to occur as quickly as we can, but that term of modulus of elasticity has been established within the industry as to which you'll have the instantaneous figure, 30 minutes, an hour, 2 hours, all the way down to 50-year lifespan. So all of the calculations, when you get into those, everything is available for you and within these calculators and the more advanced tools too. So here,
Alan,
yes,
Alan,
go ahead, Rusty.
I was going to jump in and do a plug for the PE Alliance. Alan referenced that there are other classes we do. I believe the one he was just referencing is the Engineering 301 for HDPE. And the Alliance will do those in their road shows that go about, they're scattered through the country. If you get on their website, and we'll reference that and show you our contact info later, but you can jump on those classes and learn more about polyethylene. We generally have manufacturers and field people there as well. So the other thing where you could see some of these things, at least some of it in practice, is at AWWA and some of the other big conferences. So just throwing that out there. Let you get a breath there, Alan. Thanks.
Good. Thank you, Rusty. The wealth and just robustness of things that the Alliance for PE Pipe has for you all to take a look is pretty amazing. So a picture is worth 1,000 words. A video, of course, is worth 1,000,000 words. And the way that we're all looking at technology nowadays is pushing everybody to a video. So Megan, go ahead and show us the video on horizontal directional drill, and I'll try to talk over it while we take a look.
Do you feel it? Do you feel it in the air?
Just above me, something like a dream state.
Failing, and they did not want force main material. Oh, I just lost it there. I think that might have been it. Force main material leaking onto the shore of South Beach, and what an impact that would be for it. So they took a risk with the contractor to go from a micro tunnel to a horizontal directional drill and saved probably $4 million through the process, and then used horizontal directional drill in that application very successfully. And so the industry itself is continuing to push those boundaries, and we always hear more and more and more about getting longer drills, getting larger pipe as we go through this. So the technological limits are going there. And again, when I said case studies earlier, somebody's done it at some point in time before. So we do have those case studies at the Alliance. And Rusty, thank you so much for that plug before and giving me a little breather. So we'll move on to slip line. Yeah, Rusty. Mm-hmm.
I was going to mention too, the cost savings you just mentioned. I think a big key to trenchless installations is you usually can do these in much shorter period of time. So again, those cost savings you mentioned, I believe that particular 54-inch project was done in like quite a bit, like months less than what they had allowed for the project. Is that correct?
Oh, absolutely. So in this scenario, the majority of the time was spent putting up maintenance of traffic to close off this road, and then fusing up the long lines of pipe. And then once we started that drill, we wanted to make sure that process continued. Great observation, Rusty. Absolutely.
But a very key component to the people who are evaluating that. Just a quick update. We're doing pretty good on time. It's about 1:28. So just an update for you.
Alan,
Okay,
I
great.
can add some color to that Miami project. So AECOM was given a year to do the project. They saved $4 million for the utility by doing HDD versus tunneling. They gave them a year to do the job. They did it in 5 months. Actual construction, it was done as a design build, Alan, and actual construction was 5 weeks, 24/7 during that 5-week period.
All right.
Pretty amazing.
That's it. So,
Pretty amazing for sure.
as municipalities, I've ran one for almost 10 years at the city of Castleberry as the utility manager. Seldom did we ever get to consider anything but low bid for our projects and looking at those social, environmental costs to the community. We never really get to quantify those. But here you guys go out there and everyone on the line for us. This savings in construction schedule alone is pretty massive in what we could do for a trenchless installation. So definitely, Pete and Rusty, thanks. Don't hesitate to interrupt again in the future. We have 24 questions about midway. We still got a little bit to go here. And then we're going to reserve a few more questions at the very end to have Sharon, who gave us a great introduction, guide us at the end for anything we may very well have missed. So slip lining, we're going to take advantage of a proven conduit location. So slip lining and compressive fit lining and pipe bursting, they all take advantage of the fact that we know we have a proven conduit location. So we're not out there designing from point A to point B and saying, oh, I have to have an absolute clear path that on a contractual method, if my contractor really doesn't want to do this job, I have to have something to enforce. So we're really looking at the benefits of having an existing conduit. We've got to make sure that we prepare it correctly. We provide access in the appropriate places. We provide temporary bypass and other things of that nature. So what you're looking at is a field fabricated pull head in the middle. So we are going to take a piece of high-density polyethylene through the slip line process and score it and make sure that we can get a smaller diameter start the installation process. And we want to make sure we properly prepare it as what you're seeing in the other items here as well. So there it is. We said preparation is key to successful installation. We want to make sure that it's clean on the inside. We want to make sure that any tuberculation is removed. So in metallic pipes, a tuberculation essentially is corrosion of the interior metallic surface. It brings down a nodule, I just bit my words there, a nodule that allows this room in the back side of that to be able to go through and do more corrosion. If anybody in the call has seen the inside of a 2 or 3 inch galvanized pipe for small diameter water services on cul-de-sacs, you know what I mean. So that tuberculation continued to neck down to where we almost have pinholes through that project or that pipeline through anything else. So we want to make sure that that's cleaned out, that the hose pipe can receive the slip liner as we go through. We obviously have a limited ability to pull through bends. So when we properly lay out this plan, those bends, those locations of valves, fittings, tees, they become another pull pit for us as we're looking through this. So we're going to monitor those pulling forces as we go. You can also lubricate a slip line as you would see through this. So there are ASTM standards for you in looking at the slip line process. And then we're going to get back to another video. So Megan, we've got the 48-inch going into a 50-inch ID steel pipe.
A 48-inch pipe going into a 50-inch ID. So we have about 2.5 inches clearance, or 4 inches clearance on each side, 46 inch.
bursting and the fact that everything that we're done there has to fit within the ID of that existing pipeline. So we're not allowed to bring in a new pipeline that has a larger ID than the existing pipeline. Pipe bursting, we do have that allowance themselves. So here we are, compressive.
Hey, Alan,
fits.
you might want to do since they can't
Mm-hmm.
hear during the video, you might want to just do a quick talk back over that slip lining, that it was pushed in and done very rapidly. I think you mentioned it was done in 15 minutes. I think a lot of people didn't hear that portion of your talk once the video started. So.
Gotcha. So just to clarify, can you not hear me while I'm talking over it, or can you not hear the video?
I don't think you hear I don't think you hear you. I think they're hearing the
Gotcha.
soundtrack from the video.
So, thank you. Well, sometimes not hearing me is not bad. My wife tells me that quite often. So maybe you guys, after a while, get tired of hearing me. So essentially, what we did in the slip lining video that I showed you here is we're putting a 48-inch OD into that 50-inch ID steel pipe. So we make sure that annular space is still there, that steel pipe was cleaned and allows us to be able to pull free of any obstruction into that pipeline. We fuse that long run in advance at the laydown yard or wherever we may very well be able to pull it in. And once we start that process, we don't want to stop. So this project that we showed you in the video was a very good demonstration of being able to use minimal pull forces to be able to start moving. So they were achieving fairly rigorous install or rapid install lengths as they moved it through. They started pushing into the backside and made it through that 15 or 500 foot plus in about 15 minutes for it. So it happened very quickly. Oftentimes in trenchless technology projects, most of the work happens to be the preparation. So that's fusion of the high density polyethylene in the laydown yard. By the time that people are performing any work in front of the residents or homeowners or things like that, the actual process of pulling the pipe into place where they're going to see construction activity is going to be minimized. That's another social benefit as we see through it as well. So compressive fit slip lining. Now, high-density polyethylene is the only pipeline that can be used through this. So you can't see me here, but I'm raising up my hands in a big circle for you. And what we're essentially doing is we're taking a larger OD high-density polyethylene pipe than what the ID of the existing pipeline is. Then we are temporarily reducing the OD of that high-density polyethylene pipe, pulling it in to, again, that smaller ID pipeline, and then allowing that high-density polyethylene to relax and then conform to the inner surface of that hose pipe that we have. So these can be structural, semi-structural, so can a slip line through that matter as well. But here we're resulting in no annular space through this, and we're really taking advantage of much longer pull runs to where we're seeing sometimes 92% less excavation. So the project I'm looking at for compressive fit slip lining is going to be these transmission lines of larger diameters that are pre-stressed concrete cylinder pipe, or some other type of pipeline that has multiple components in it that cannot be pipe burst. So the longer lengths between valves and control valves in a transmission main is going to give us a higher productivity as we go through. So those are some of the things to keep in mind when you're looking at your rehabilitation projects you're evaluating, that this is one of the prime successes for compressive fit slip lining for transmission mains, large diameters, pre-stressed concrete cylinder pipe that may very well be failing early. So here's a little animated GIF in the slideshow. I hope you can see it. If you can't see it, we're going to walk through it as well in a picture in a couple minutes or two. But again, we're temporarily reducing the OD of that pipeline through either a dye reducer. They have multiple methods to be able to make sure that this moves through. And then we're pushing that pipeline or pulling pulling that pipeline through that existing pipeline and continuing to go through as we see here. So we've got some confirmation that you guys can see the video. That's awesome. Of course, videos make everything that much better, and so do your questions, by the way. We are on question number 38, so it is continuing to go and go and go, and I love it. It's fantastic for us. Here are some more of the functionality of how we're looking at getting that into the existing pipeline. So there's a reducing die, a towing head, original pipeline as we see, and now imagine that the forces that are put upon that reducing die and that towing head are fairly large, especially in comparison to a slip lining project or a pipe bursting project as we move through. So we often have to reinforce the interface at the soil surface when we're starting to push that pipe through, and we've had that die reducer lodged and secured up against either our shoring or a concrete dead man in some instances. And then what you'll see in the bottom left picture here is actual oil that's sprayed onto the pipeline to get that lubricated and start to go through. You can use, canola oil, or if you like olive oil, it'd be a little bit more expensive, but you can use any type of oil that you want there to be able to spray on that pipe and make sure we continue to keep that process rolling as we go through. Some of the same things with slip lining as we're looking at. We want to make sure that that interior surface of the pipe is prepared properly. So on the right picture, you'll see a scraper head that is pulled through that pipeline, and that continues to remove that tuberculation that we talked about and bring it through with it. And then we'll have a proving pig. So that proving pig then happens to be the same diameter of the high-density polyethylene as we go through. So we just had a question from Gabriel Pena. And can the pipe get stuck in the compressive fit lining method? And Gabriel, the pipe can get stuck in any of the trenchless methods that we're talking about. So it's that mitigation of the getting the pipe stuck program that has to work in our favor. And every supervisor and foreman on the job that does these projects understands that, and they have a plan ready for this. So in the act of compressive fit lining, if something goes wrong, we didn't clear that obstruction, we have some type of failure in the mechanism of the pulling operation as it goes through, that would become another point of excavation that we now have to dig down, remove that obstruction, and continue the process through. In the case of horizontal directional drill, obviously we can't easily dig down in a river, so they'll try to bring in larger equipment and continue to move that pipeline along as we go through. But great observation, and on question 41, you guys are sticking right with us and continuing to ask, and I love it. So here's just another example.
It's about just a quick time check. It's about 12:42, so we've got about 13 minutes, 18 minutes left, just to give you a heads up.
All right. I love compressive fit lining, so obviously I've been talking about it too much. Let's go straight to one of these that'll show you directly with dimensions, so you could see what I'm talking about. So we are taking a 32-inch HDPE OD and putting it into a 30-inch cast iron hose pipe. 29-inch HDPE under tension. That material does go somewhere. The pipe does lengthen as we put through this. And then again, we have the relaxation of that pipe within that 2 to 24-hour time period. I've seen a compression fit lining process stop its advance from equipment failure, and that relaxation period occurred over a 2-hour period at this die reducer. It was amazing to see. This does not harm the pipe. This does not do any damage to the pipe in a long-term effect at all. We're fitting within the allowable radius, the allowable deformation, and yield of the pipeline as we move through it. And again, HDPE is the only pipe material that can do this for you to maintain that largest ID through a lining process that we could possibly muster. So I'll get into pipe bursting. I myself have designed over 45 miles of pipe bursting projects itself. So I have done a lot of this before time, and a lot of things that you could do out there. Get out there and pipe burst. It's pretty simple. For pneumatic pipe bursting, high-density polyethylene, again, is the only pipe material that can be used for that. Similar to compressive fit lining, but this is pneumatic. And the reason why this happens is that impact hammer is used to break this pipe as we're inching along through the existing pipeline. It's connected to a constant tension winch, which fully aligns that expander head up against the face of that existing pipeline. Air compression is put through an air hose, and then we're just breaking that existing pipeline incrementally through it. Gravity sewer pipe bursting is the number one pipe bursting method throughout the United States. Can only use high-density polyethylene. And the programs we're talking, the city of Houston is one of the largest consumers of HDPE on its gravity sewer side, at almost 80,000 plus linear feet a month to replace its gravity sewer systems as we go through. Here's some tools for you. This is a pilot connected to an expander head. What you'll see on the left then becomes just a impact hammer that has yet to be connected to an expander head. As that project diameter goes up, so does the size of equipment as we're moving through it. We're continuing to connect that expander head to the high-density polyethylene through a whole litany of different screws, as you're seeing through these pictures as we see. The one on the left also shows you a lubrication port behind it, as to which case we're putting a hose through the pipeline and pumping lubrication through to be able to help reduce the friction through that. Pneumatic pipe bursting has the luxury of having, in some instances, one less excavation. As we're able to advance that impact hammer and expander head through to an existing manhole, we still have to excavate on the opposite side of the launch pit where we're going to start it. Then we'll remove that expander head from the impact hammer out of the existing manhole, and then we'll back that impact hammer out through that production pipeline. So we can end up with even one less excavation than we have through a regular pneumatic system. You do have to excavate down to reinstate the service connections. One of the true benefits of high-density polyethylene is those can be electrofused or fused on at that situation, so you'll have a seismically resistant or soil displacement resistant service connection that is hard connect. And we're also going to make sure that there's no moisture, since it's hard connected to get through there, unlike CIPP, which can oftentimes, if that grout breaks down over time, then you can get moisture through that. Static pipe bursting is often used for potable water mains. It uses a hydraulic power pack. Yeah.
Hey, just want to jump in real quick. Again, for our listeners, one of the other main attributes of doing this pipe bursting is if you've got asbestos cement piping in your system, pipe bursting allows you to leave that pipe in place. It becomes a hazardous material once it touches the air or becomes, out of the ground, and then you've got a problem. By using the pipe bursting, you're minimizing the hazardous waste you have to dispose of. So it can be a definite solution. And I'm kind of preaching to the choir here, Alan. I know you had, have written a book and have done quite a bit on that particular thing. But I think it's important for the people that are with us today to hear that. It's kind of one of those extra benefits that really can help you with that. So.
Absolutely. AC pipe bursting can be done legally in accordance with regulations and has been done in Florida, Michigan, Texas. It's been an approved alternate process in the state of Vermont and also in California, right in the Bay Area. So just a quick thing, everything that shows for air sampling during pipe bursting process has come back negative in exposure for release of potential asbestos fibers. That's an entirely different conversation. You're more than welcome to reach me at Alan Ambler at amtrenchless.com or aambler@pepipe.org as we go through that and look at asbestos cement pipe bursting. So I'm going to run through this. We've got a whole lot of material still left, and the questions are coming great. So we're at 49 right now. These are just extraction cages where you can remove the equipment on a static pipe bursting rig right in front of a machine, the pipe bursting machine that does all the work for us. And then here, for pipe bursting in suburban or urban environments, I liken the excavations to surgical excavations. So when we go through developed neighborhoods, we can make sure that some of these pipe excavations that we're looking at, of course, based on the depth of the connection that we're seeing, is we get really, really small in some of these. So we're dramatically minimizing those excavations as you're looking through. Existing pipes that can be burst, here's some lists for you. They're broken into fracturable materials and non-fracturable materials. So the way that these pipes fail and the apparatus that we have to use to be able to either split them, cut them, or otherwise treat them prior to the expander head comes through is different. But there's a tool for everything, and that pipe bursting community has figured out quite a bit of this for you as well. I talked about pre-stressed concrete cylinder pipe. It is an interactive pipe that has multiple components, and a lot of that is reinforced. It cannot be burst in that manner. Challenging for bursting are going to be a ductile iron or a corrugated metal pipe. As you can see here in the picture on the right, some of that corrugated metal pipe accordions up. It has a lot of stored energy. While it pulls off of the head, we have to cut it then, and then it could release that energy as we're going through. Range of diameters and lengths, they can be done up to 54-inch and long pulls. But again, the system that we are rehabilitating is going to be one of these that defines the lengths for us. So in gravity sewers, we're looking at 300-foot manhole spacing, which becomes an excavation. Or if we have a reversible hammer, that saves us an excavation. And in potable water distribution systems, the presence of the valve stops us from being able to burst through it. So that's a 300 to 500-foot length. We want to look at making sure that these crews are as productive as we can, so we drive the cost of construction down as we go through. In pipe bursting versus open cut, I use the term surgical excavation. There's also a lot of other great benefits of reduced carbon emissions, traffic impacts. We've talked about a lot of these already just based on trenchless technology alone. So some of the things we're looking at, if we cannot access that pipeline through an excavation, whether or not it be underneath the railroad, underneath 2 miles of concrete encasement or something of that nature, that in a planning study is going to be what's going to stop us from accessing that pipeline and saying, hey, look, we got to look at a different method here for us. So some of the best conditions for us for geotechnical, we're looking at that original compacted backfill. Worst conditions are going to be rock. Obviously, in a carved rock trench, we can't displace that material somewhere. So we're continuing to look through in that manner as we want to know trench conditions as we move through. That allowable bending radius now shows it for us in moving that pipe from the laydown yard to the actual interface of the pipe bursting mechanism, and allows us to be able to have the best, most forgivable radius as we put that pipeline into place. And maintenance of traffic sometimes is still a consideration, obviously, while we're doing all these trenchless projects. What you'll see in the right picture here becomes a project for the city of Tampa, as to which we did pipe bursting underneath a heavily traveled roadway that had 76,000 average annual daily traffic. We did the work at night from 7 p.m. to 5 a.m. And then we took the construction schedule and reduced it from 6 to 9 months down to 3 weeks. So we're taking advantage quite a bit of time period savings through trenchless. Again, I'm going to continue to move through some of this pretty quickly, and then another couple of minutes here we'll wrap up with some of the best questions we've got, or at least the most poignant to the process itself. Temporary bypass is one of these processes to which they constantly use high-density polyethylene pipe throughout it. And contractors can get pretty creative as to how they push their systems through and maintain that service during rehabilitation of the pipeline itself. I know you're curious about connections. There's lots of different ways to do service connections, mainline reconnections, electrofusion fittings, mechanical fittings. All of the other things of that nature are becoming much more robust, and the industry itself has innovated fairly substantially. Rusty, do you want to come on and tell what Core and Main has as far as the available inventory for everybody when they're starting to look at starting their own trenchless projects?
Sure. I mean, we are happy to help with anything and support any projects that you have. So once you determine what you want to use, we could do anything from electrofuse like we're showing there. And really, fusion is always going to be the number one connecting method when it comes to polyethylene. I think that's definitely going to be your best bet. But you've got mechanical fittings as well. You've got tap saddles. You've got some, kind of a combination that's a hybrid of the two. So probably the best thing to do, in just the interest of time, contact me. We'll be happy to get you hooked up with our local, whatever local branch we have near you, and come up with the best solution for what you're trying to accomplish. But we can do, again, mechanical, electrofusion, or a hybrid between the two. And, of course, we always like to see fusion, and that's one thing we didn't really cover a lot today. Hopefully most people are familiar with polyethylene, but that fusible joint gives you a zero leak rate. You're not putting in an allowable leakage rate from day one that only gets worse over time. So, again, another huge benefit to polyethylene.
Yep. Pipe scraping and gouging, we talked about that. 10% allowance for most of the pulling over the roadway surfaces. Those are going to be okay gouges as we looked at. Here's an example of a gouge that is bad. This one we discovered at 3 a.m. and I said, Chin, who's the supervisor in the job, when in doubt, cut it out. In the process of using this 8-inch pipe, after we cut that joint out, 5-foot section, really was accomplished within 20 minutes, and the pull continued. So here we use dry chainsaws, which do not contaminate that pull itself, and then we just advance the process through that. So just to make it easier for everybody out there, here's email addresses for everyone that's part of the call. Kudos to everybody out there on the call, as I'm starting to hear from Dan and Pete that you guys were asking absolutely fantastic questions and keeping them moving and moving and moving. And it looks like we're at well over 50 questions. And thank you guys very much. Those questions make our interaction that much better, because we know we can't cover everything. We try as much as we can in all of the detailed detailed presentations that we have. But this one focused a lot more just trenchless technology, and Rusty was right on the money there, hoping that you guys knew a whole lot more of high-density polyethylene. And some of those fusion questions, material questions weren't really right on the forefront for you. But if they were, we do offer 101s, 301s, lots of different other webinars through the Alliance for PE Pipe to be able to come through. So, Pete,
hey, Alan,
Rusty,
did you talk about the engineers package?
I briefly at the very beginning, but here again, I'll talk about it here as well. Just email any one of us, and we'll give you a whole lot of comprehensive information on the design calculations, the references as to where some of these came from that we are able to give you that are free, and then also specifications that the Alliance maintains, typical details. We also write typical details and create them for you in AutoCAD if you have a preference that's something that's not included in the package and want to see that as it's done. So here again are the contact informations that we have, and then also if Sharon or anybody else wanted to come on with some questions that we should elaborate on or missed in that manner, we've only got a couple of minutes for it, but thank you guys very much for tolerating these and move pretty quick.
Yeah, great job, Alan. I'd just like to say to our audience as well, the engineers, we do offer PDHs, so you have to ask for them. So send Dan Landy an email saying, hey, can I have a PDH? I attended. We'll check the log, make sure you're there, and we will send you a PDH. Thank you very much.
Yeah, great
awesome
presentation. Hopefully you guys got our contact info there. And again, we're here to support. I mean, the four of us that are up on the screen right now, what we do is go out and promote polyethylene and help people, convert their specs to it. So please give us a call. Again, Core and Main can help with your other, valves, everything else that goes with it, so we can support you fully through that. So any other questions or anything that we should discuss?
Hey guys, I'm just letting you know that we're up against the clock. It's coming up on the top of the hour. And I know you answered a great many questions throughout this entire presentation, which was fantastic. So I'm going to have to end it there. So this concludes this session of the Trenchless Technology webinar series. I want to thank all of our presenters, for taking part, and thank all the attendees for joining us today. As a reminder, today's webinar will be archived at trenchlesstechnology.com if there's something you missed or would like to refer back to. So thank you again, and we look forward to seeing you online at a future webinar.
Thank you.